Data structure. A data structure is an organized way of storing, managing, and accessing information within a software system. It defines how data is collected, grouped, and interrelated to represent real-world objects or processes. Effective data structuring enables software applications to efficiently retrieve, update, and analyze information supporting both day-to-day operations and high-level decision-making. Table. In the context of relational databases, a table is a fundamental component of the data structure. A table is like a spreadsheet. It organizes information into rows and columns. Each table typically represents a single entity or concept, such as users, products, orders, or events. Every row in a table is called a record and represents a unique instance of that entity, for example, a specific user or product. Every column is a field and defines a specific piece of information to be stored, such as name, price, or creation date. Fields or columns. Fields are the individual data elements that make up the columns of a table. Each field holds a particular type of data, such as numbers, text, dates, or even files. For example, in a user table, common fields might include user ID, a unique identifier, name, email, and date created. Fields define what kind of information the table stores and often include rules about the type of data allowed, maximum length, or whether a value is required or optional. Roles. Roles refer to the different types of users who interact with a system and the permissions or authorizations assigned to each. Roles define what actions each user type is allowed to perform within the application, such as reading data, creating new records, updating existing ones, or deleting entries. Common roles in business applications might include administrator, manager, editor, and end user. Role-based access control is a key security practice that ensures users can only access or modify data that's relevant to their responsibilities. Relationships. Relationships describe how tables are linked or associated with one another within a data structure. These connections are crucial for organizing complex information and ensuring data integrity. The most common types of relationships are one-to-one. Each record in Table A relates to one and only one record in Table B, e.g., each user has a single profile. One-to-many. A single record in Table A can relate to multiple records in Table B, e.g., one customer can have many orders. Many-to-many. Records in Table A can be associated with multiple records in Table B and vice versa, e.g., students and courses. Students can enroll in many courses, and courses can have many students. Relationships are established using keys unique identifiers like primary keys and foreign keys, which ensure the correct connection between related records across tables. In summary, together, data structures, tables, fields, roles, and relationships provide the foundation for modern software systems. Well-designed data structures help ensure that applications are secure, flexible, and scalable, making it possible to store, retrieve, and analyze information in powerful and meaningful ways. With OrganAI, all these are easy way for you. You don't need to do it with touching your schema template. But if you want to have a huge system in minutes, planning it with schema makes you faster to have a ready-to-use system.